Hey, universe explorers, have you ever looked up at the night sky and wondered what lies behind the millions of stars? It's beautiful, it's peaceful, but the reality is that up there, hidden in the darkness, are the biggest and most mysterious monsters of the cosmos, supermassive black holes. Now, let's be realistic. No other cosmic object makes us ask so many questions. What are they? How do they appear? What would happen if we fell into one? And why, despite the fact that they seem scary, are they actually essential to the existence of galaxies and, implicitly, to our existence? Hold on tight, because what follows is not just an astronomy lesson, it's a journey through space and time, a story about invisible giants that defy logic and the laws of nature as we know them. Think of it this way: if our sun were like a light bulb in a large room, a supermassive black hole would be a kind of giant cosmic vacuum cleaner, sucking up anything that gets too close. But, paradoxically, without it, our galaxy as we know it wouldn't even exist. And the brilliant part, right now, at the center of the Milky Way, there's just such a monster. It's called Sagittarius A, and it's millions of times more massive than the Sunday. Yes, right in the middle of our galaxy lurks an invisible giant that influences the orbits of every star, including our Sunday. And yet, we have no reason to be scared. Quite the opposite. These supermassives are the hidden heart of galaxies. They're the gravitational engines that shape the universe. What are supermassive black holes and how big can they be? We already know the concept of a normal black hole. It's what's left after a giant star runs out of fuel and collapses under its own weight. Basically, the gravity becomes so strong that nothing can escape, not even light. But these are regular black holes, with masses several times greater than our Sunday. Supermassive black holes, on the other hand, are in a different league. Here we're talking about monsters with masses of millions or even billions of suns. Think of it this way: if a normal black hole is like a mountain, a supermassive hole is like an entire continent. The difference is colossal. To give you an idea, at the center of our galaxy, Sagittarius A has about 4 million solar masses. That sounds huge, but wait and see. In some distant galaxies, supermassives with over 10 billion times the mass of the Sun have been discovered. If the Sun were a grain of sand, that black hole would be the size of an apartment building in a city. And the cool thing, despite their monstrous size, they're not like cosmic vacuum cleaners that just suck everything in at random. If you're far enough away, you don't even feel their gravity. Planets, stars, even us, with our sun, live peacefully on the outskirts of the galaxy, not being pulled in. But then, how does something so huge form? Well, that's another one of the great mysteries of astrophysics. There are a few theories. One says they started out as regular black holes formed from massive stars, which then slowly grew, swallowing gas, dust, and stars around them. Another suggests they formed directly from the collapse of giant gas clouds in the early days of the universe. Whatever the truth, these supermassives have been there since the early days of the cosmos, shaping the galaxies around them. And the coolest part, almost every large galaxy has one. Wherever you look in the universe, whether it's a graceful spiral galaxy or a huge elliptical one, you'll find one at its center. They're like cosmic signatures. If you see a galaxy, it almost certainly has a supermassive black hole at its center. Detection and first image of a black hole. Okay, now comes the even more interesting part. If a supermassive black hole swallows all light and is invisible, how the hell do we know it exists? Well, this is where the brilliant ingenuity of scientists comes in. We can't see black holes directly, but we can observe their effects on other objects. It's like when the wind blows. You can't see it, but you can see the trees swaying. In the case of black holes, the trees are the surrounding stars. Astronomers look at a seemingly empty area of space and see stars orbiting around something invisible. At dizzying speed. S, for example, at the center of our galaxy. Y, some stars spin at thousands of kilometers per second around a point that emits no light. T, the only logical explanation. N, there's an object of enormous mass there. Namely Sagittarius A, the Milky Way supermassive black hole. But that's not all. When matter, gas, dust, even entire stars falls into a black hole, it heats up to millions of degrees and emits extremely powerful radiation. Basically, before it is swallowed, the matter lights up like a giant cosmic light bulb. These accretion disks are among the brightest phenomena in the universe. The ultimate irony, something invisible becomes visible through the havoc it wreaks around it. And now comes the wow moment. In April 2019, humanity saw for the first time something that until then was only a theory. The Event Horizon Telescope Project, a global network of telescopes, managed to capture the first image of a black hole. You know that photo with a diffuse orange circle, like a ring of fire? That's not a meme, it's reality. What you see there is the shadow of a black hole in the galaxy Messier 87, located 55 million light-years away. Imagine the excitement, thousands of scientists working for years, synchronizing telescopes around the world, just to capture a photo of the impossible. And they did it. It was like the first time humans set foot on the moon, a moment that made us feel, once again, that we were witnessing an incredibly mysterious and vast universe. But you know what's even cooler? In 2022, the team did it again, this time with Sagittarius A, the black hole at the center of our galaxy. We were basically able to see the cosmic monster that lies right in the heart of where we live. So even though we can't look directly into the abyss of a black hole, science has given us new eyes, and honestly, each new image not only answers questions, it raises even bigger ones. What else can we discover? Where is the limit? The role of supermassive black holes in the formation and evolution of galaxies. If we were to describe the universe as a cosmic metropolis, then galaxies would be the cities. And guess who are the invisible mayors? The ones who dictate order, traffic, and how the city grows. Exactly, supermassive black holes. Although at first glance they seem like monsters that swallow everything in their path, the reality is that they have a much more complex role. Studies show that almost every galaxy has a supermassive black hole at its center, and it's no coincidence. The relationship between a galaxy and its central black hole is like a kind of cosmic dance. Both grow and evolve together. Let's take an example. When a black hole feeds on gas and dust, it emits colossal jets of energy and particles. These jets can stop the formation of new stars or, paradoxically, stimulate the emergence of others. Basically, the black hole decides the pace at which the galaxy develops, like an invisible conductor controlling the cosmic orchestra. And here comes the fascinating part. Measurements made by astronomers have shown a direct link between the size of a black hole and the size of its galaxy. If the hole grows, so does the galaxy. It's as if they are connected by an invisible thread, keeping them in balance. Moreover, these interactions don't just happen on a small scale. There are entire galaxies that collide and merge, and their black holes at the centers end up dancing around each other until they merge into a single giant. Imagine the forces involved there. Billions of suns thrown into a spiral, gravitational waves propagating through the universe like waves on a lake. But perhaps the most surprising part is that, without these black holes, the universe would look completely different. Galaxies would be much more chaotic, without a clear structure, perhaps incapable of forming stable star systems. In other words, without these gravitational beasts, we wouldn't be here to ask questions about them either. And yet, the more we understand, the deeper the mystery becomes. If supermassive black holes are so essential, then the question is, do they have an even greater purpose in the architecture of the universe, or are they just natural consequences of the laws of physics? One thing is clear, their role is not just to devour, but to create order in a seemingly infinite chaos. This, paradoxically, transforms them from monsters into cosmic architects.
And here we are, after a journey through the depths of the universe, face to face with some of the most enigmatic and powerful cosmic entities, supermassive black holes. From their mysterious formation, to their role as architects of galaxies, to the historic images captured by humanity, each step has brought us closer to understanding them, and yet, the mystery remains. Perhaps that is the beauty of these invisible giants. They are not just monsters that devour everything they touch, they are symbols of the unknown, challenges placed in our path to push us ever further. They remind us that the universe is not a quiet and predictable place, but a huge spectacle of forces, light and darkness. And, honestly, perhaps the most important thing these discoveries give us is not just knowledge, but perspective. They show us how small we are and, at the same time, how big we can become when we unite our curiosity and intelligence. Because the image of a black hole is not just a snapshot of the cosmos, it is proof that humanity, this tiny species on a blue planet, dared to look the impossible in the face and capture it. So, the next time you look up at the sky, remember, up there, hidden in the shadows of galaxies, are the invisible titans that shape the universe, and every question we ask about them is actually a question about us, about how far we can go. Because, in the end, the universe is not just a place we live in, the universe is our story, and supermassive black holes are the most dramatic and fascinating chapters in it.